Hello, my name is Radimus. I'm going to be going over my solution to problem number 2 in our group assignment number 4. So what we have to do for this one is we're supposed to take this recursive algorithm and kind of find a solution to it using an iterative substitution technique, I believe it's called. So what I went ahead and I did for this problem is I start here. That lets me know that I'm supposed to be plugging in this entire function to that specific area. So if you kind of take this part and substitute the whole thing into there for t of n, but divide it by 2, you get this. And that is going to keep on repeating itself for infinity. So we're supposed to look for some patterns, and lo and behold, it kind of follows this sort of pattern of t of n over 2 divided by 2 to the I minus 1, and so on and so forth with all these n's that just accumulate and divided by 2 to the power of I minus a number. So one thing that we should be looking for is ways to simplify t to the n over 2 into something. And lo and behold, if you take this this portion that's constantly iterating where the arrows are, then you'll start to see this pattern that is pretty much the same exact thing as this. T to the n over 2 divided by 2 to the I minus 1 is equal to t of n divided by 2 to the power of I. And that's nice because we can plug that in right here into the formula and then just pull out the n from this entire portion. So the n times the whatever infinite part, and we have t of n over 2i here. So now we want to simplify this even further using the property that we were given. I'm assuming, okay, so this is what the problem says, and this is what I see. I see this big beta symbol, and if I open it up in an alternative document format, it looks more like an arrow, so I'm confused on what this is supposed to be. But, you know, from all this different examples I've seen, they use a theta symbol there, so I'm going to go ahead and assume that's supposed to be a theta symbol, and this is the property that we're given there. So we can take our substitution that we made over here using this property to set that equal to 1 if I is the log star. Log star is a recursive algorithm, and I'm not 100% sure if I remember how it goes. It's something like this, where it'll be 0 if our n is, I think, something about it being related to 1. If it's greater than 1, then it'll do something. If it's less than 1, then it does something else. And the other possibility is 1 plus log star I believe that's how it goes. So yeah, pretty much what it does is it keeps going, reiterating through itself until it condenses the number down to something smaller, and it'll just stop once n is less than 1. So I think that's this one will be n is less than 1 and is greater than 1. Don't take my word for that, but it looks something like that. That's the recursive algorithm, and that nifty substitution that we do right there allows us to simplify this even further by setting this whole thing equal to theta of n if we substitute I for log star right here. Then we can plug that whole thing, this, to substitute with this, since I has been become log star, and this is our summation. Obviously n times this whole portion over here, and that is going to be 1/2 to the power of I. So yeah, that's pretty much the whole gist. If you guys have any other questions regarding this and need any other clarifications, please let me know. Or if you guys have any better ideas on how to solve this problem. But as far as I can think, I hope I have a good solution. So yeah, let me know what you guys got.